Hi, my name's Jeff Wilkerson, astrophysicist here at Luther College, and today I'd like to talk to you just a little bit about the joys of teaching a general astronomy class at Luther. Would be a class that we teach primarily for students not majoring in sciences, although some students majoring in sciences would take the class. It's not intended for physics majors. We have an astrophysics class for that. And the general astronomy class, then, I gear toward thinking about the process of science and how people understand the universe and sort of our interaction with understanding the universe as human beings, primarily over the last 400 years or so, but a little bit prior to that as well, and sort of what it means to be human. How is that interaction, that drive to understand what the universe is, where we are in the universe, who we are in the universe? How's that a uniquely human thing? How does that make us the human beings that we are, or at least express something about our humanity? And so it's geared to be thinking about that as much as anything else. I often talk about all the teaching that I do here and all the work that I do here. We're located here in the beautiful corner of Northeast Iowa, and I love being outdoors. And I get outdoors and hike around here as much as I can and get out in beautiful wild spaces. But I tell people that when I'm out doing that kind of stuff, I can never, ever completely shut it off. That is to say, there's a little bit of work eating at the back of my head, even when I'm out there in these wild spaces. It's still there, and I'm still thinking about work kinds of things often. And what I've found is the only time that disappears completely, where I'm not thinking about whatever that is, budgets, normalizing data sets, thinking about what needs to be done by tomorrow or the next day. The only time there's not a little tiny bit of that eaten into my brain someplace is when I walk through the door to the classroom and students and I are talking about the material for the day, talking about the universe. And that's true whether that's an upper level astrophysics class or an upper level thermodynamics class for physics majors that has 5 or 6 or 8 people in it, or a general astronomy class designed for students who are trying to satisfy their natural world lab requirements, and it's a classroom full of 40 or 50 or 60 people in it sometimes, maybe 30 or 20, but whatever that happens to be. I walk through that door, and for that hour or that hour and a half or whatever else it is we have going on, whatever that time is, there's nothing else in the world except me, the students, the material, and our interaction regarding that. And I feel a part of something there that is self-contained. Everything else goes away. It's just beautiful. So I want to talk to you a little bit about the astronomy class where that happens. You know, we meet 3 times a week. If it's during the semester, I have taught it during January term before, but if we're during the semester, we meet 3 times a week and discuss the material, and then we meet once a week in laboratory and go through laboratory experiments and talk about practice the ways humans have understood the universe. We try to practice how humans making decisions matter in the universe and understanding the universe. To say that every time we do an experiment, every time we do an observation, we're making decisions and we're doing the work and we're trying to understand the best way to take the data, interpret the data, analyze the data, process the data, whatever it is you're talking about. We're doing that. In the end, we have to say, did we learn anything about the universe? And did we mess that process up along the way in such a way that it polluted what we were trying to do just a little bit and maybe is a little more confused? And we have to be careful about that. And in the end, we have to take a step. And I tell students all the time that, if you feel like you've learned something about the universe, no matter how small it is, it's a very lonely place. You're standing on the lip of an abyss, and there's no guidelines to talk about whether you actually did everything you needed to do to understand that thoroughly. And sooner or later, you just have to step into that. You have to decide when it's right and take that step into the abyss and make the decision to say, yeah, I'm going to tell the world I think I know something about the universe that's different from what anybody else has known before, and I may have it wrong, and I may always have it wrong, but I may have it right too, or at least approaching right. And so that's the kind of thing we're trying to model in the laboratory component, but in the other component of the course as well. So we teach the entire universe in 14 weeks. We go in and we talk about the universe, from understanding the move from heliocentrism to geocentrism to heliocentrism, a sun-centered solar system versus an earth-centered solar system, and what we can tell by just making simple observations of the patterns of stars and star motions across the sky, all the way to Big Bang cosmology, up through galaxies and clusters of galaxies, and dark matter and dark energy, and the history and future of the universe. And we do all of that in 14 weeks. Now, there's a big debate in teaching astronomy. People are out there talking about whether you can actually do that or not, or whether you should have a course that's focused only on the solar system, or a course that's focused only on the universe, only on galaxies and stars, and bigger aspects of the universe, to say you can't learn all of that in 14 weeks. And probably people are right if your goal is to learn content material about facts about how the universe functions. And we like to learn some of that, but that's not our primary goal, recall. Our primary goal is to understand how humans have struggled to understand the universe, how this is a uniquely human endeavor. So it is that when we're teaching astronomy and we talk about the move to heliocentrism, a large part of that is about how Galileo struggled, how Kepler struggled, particularly how Kepler struggled, how Tycho Brahe struggled, how these three working together and apart, but on the same data and in the same, asking the same question of the universe, how they came to develop a new understanding of the universe and what it meant to work with the understanding we had prior, and how it fed the understanding that came later, and how human drive and human emotion and human frailty and human strength and human beauty and human dignity and human failings, and all of that was wrapped up in how these people interacted, how they thought about what they were doing, how they approached answering this question, and what a wonderful, beautiful tapestry of understanding came out the other side. So if we look at that, and then we look at the move in the 20th century to try to understand whether what we called spiral nebulae at that time were relatively small clouds of gas within the Milky Way, our galaxy, or whether they were themselves external galaxies, like the Milky Way, big conglomerations, tens, hundreds of billions of stars, clumped together by gravity in space, their own self-gravitating islands of stars. And there were competing models about what these were, and the human struggle to understand, do we know enough? Have we measured enough to be able to know which of these models is the better model? And so we look at that and we understand, well, what's the data? And how did we interpret the data? And how might we have interpreted the data otherwise? How did these people interpret the data? Why from our perspective, did they get it wrong when they interpreted the data? And why do we think we have it right now? And why might we be wrong about us having it right? But then you have the same kind of story. I hope that what students can see is that there's the same kind of story playing out of struggling with data, living right on the edge of having enough data, sufficient data, good enough data for us to be able to answer the question we want to have, always pushing at the edges. And it's a different cast of people. You've got Vesto Slipher, and you've got Edwin Hubble, and you've got Harlow Shapley and Haber Curtis, and all of these people on different sides. Adrian von Manen is a key player in there, on different sides of this question, trying to understand what the nature of these spiral nebulae are, and having these different models, and struggling because we don't quite have enough data. The data is not quite good enough. We're pushing to try to make it better all the time and make it better all the time and get there. And that's that human drive. That's the thing that is to do this, to get this better knowledge of the universe. But I hope that we can see that we're learning these things and studying these things and struggling these things, and the human story in that cast of characters is not unlike the human story. It's at least related to the human story in the cast of characters in the move to heliocentrism. So we jump forward to more modern questions about Vera Rubin studying dark matter, and then us trying to understand the nature of what dark matter is, and how dark energy comes around, and what she had to do to try to get people to believe that dark matter might actually be a thing, and something we need to study. And we have a new cast of characters, and we see that same story playing out, and it seems like it might take a long time. It seems like we're struggling against this for decades. decades. But then we look back at the old stories and realize, well, we struggle with those for decades too, and that we are part, all of us are part of this ongoing story. The astronomy story, the need, the struggle to understand the universe is our story. It's our story of our humanity, of our trying to build knowledge there together. So when we are in the laboratory doing this work, or when we're in the lecture discussion room talking about this stuff, we are part of that. We are part of this wonderful tapestry that is our need, our drive to understand the universe. And so that's what we're trying to get. And we get that best, I think, by looking at the whole universe in 14 weeks and understanding how that's one story of humanity, and figuring out who we are and where we are and how we've gone about it. And the story that comes out the other side is beautiful. It really is. It's one of the greater stories that human beings can tell. How much we think we can say about the universe. What a wonderfully self-consistent, detailed model of the universe we have. I can stand up in front of a class and I can say the universe is 13.7 billion years old. And I can say this is what happened in the first 3 minutes after the Big Bang. And this is how a star evolves after it fuses all of the hydrogen in its helium. And this is where all of the heavy elements that make the beautiful things around us here on Earth, where these came from, and all of this. And it is really a remarkable testament to the human spirit, to humanity, that we've done this in the last few hundred years and can build this really beautifully self-consistent story. You know, sometimes people think that modern astronomy diminishes the human, because we're not even made of the same stuff that most of the universe is made of. The dark matter, that looks to be something we'd call non-baryonic, not like the stuff that makes us up. And so so there's this wonderful duality there, where we do become smaller and smaller and smaller pieces of the universe when you look at it one way. But when you look at it another way, for us to have been able to build this story, my goodness, that's a testament to the human being, and something that is fantastic. And that's what we try to do in 14 weeks of astronomy here, is we try to touch that. We try to make that our story, recognize that it is our story, and own that and build that and be part of that. And I feel like at a nice, wonderful liberal arts college here, Luther College, I can do that kind of work in a way that fits right at home. It's a part of what we're trying to do overall, as we make this journey through a Luther College education. And I can be a small part of that, and understanding that way it's really something special. I've been doing it here for over 20 years. And there isn't a time I walk through that door that it's not still a special thing to be able to be thinking that way about the universe with students, and bringing another group of students along in this journey, and helping just a little bit put those pieces together. So that's what I got for you here today. It's a pleasure. It's an honor to be able to do this. I tell people all the time that it's a scam. I've made my living my entire adult life by studying the universe and talking to people about the universe, and having a conversation about meaning in the universe and what the universe is. And I feel like the most fortunate person around to be able to do this. And so that's what we're trying to get done in the astronomy class. My name again is Jeff Wilkerson. If you have questions about how we teach astronomy, what we do with astronomy here at Luther College, feel free to contact me at wilkerje@luther.edu. And I am more than happy, I'm excited, in fact, to talk to you about the universe and the kinds of things we do to try to understand the universe. So have a good day, and be thinking about the universe and the world at large out there.